In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Aaron Syme, founder and CEO of WebRTC Ventures. WebRTC Ventures is a custom design and development agency focused on building live video applications. We're here to help you take your application live. You can learn more about us at webrtc.ventures. Thanks for joining us live today on YouTube, LinkedIn, and Twitch, and welcome also to any of you watching a replay of today's event. For those of us with you live, you can ask questions throughout the stream by leaving a comment in whichever platform you're viewing this on. For today's episode, I'd like to welcome David Pietramala, Vice President of Global Sales at Subspace, where he helps their customers achieve maximum value with Subspace's real-time network services. Thanks for joining me today, Dave.
Oh, thank you, Aaron. I want to thank you and WebRTC Ventures for hosting me today. Looking forward to the discussion.
Yeah, no, very pleased to have you here. Definitely, Subspace is a company that we're hearing more and more about in the WebRTC space. Although I understand you could use it for things beyond WebRTC as well. But let's start with kind of give us a little definition, a little description of what Subspace does.
Yeah, no, I appreciate it. So, I mean, what Subspace has built is, think of it as a global parallel internet. We've built a network optimized for real-time traffic. So its design is not for pushing volume of traffic to one endpoint. It's about anywhere to anywhere connectivity, and how do we optimize the experience back and forth so we can deliver quality, stability, and I'll call it an optimized performance for any type of real-time surface, which includes obviously WebRTC. So in-network apps to facilitate it, make it easy to use the network for critical applications that are driven around real-time use cases.
Yeah, can you tell us a little bit about how it works? It's how it's working on that global scale to bring things more real time.
Yeah. So if I give you a good analogy, we look like a CDN, right? We have POPs all around the world, basically hardened POPs in data centers, connected and eyeballing, peering with all the global broadband providers. So that gives us what I'll call local last mile connectivity, so the users can easily ingress on the network and access the services. So we look like a CDN, right, in terms of architecture, and it's an Anycast network. So even though we're like 137 plus POPs around the world, it looks like one POP. When you use the network, it looks like one local area network. So it's optimizing traffic and making that global connectivity look like it's a local area network, right? That's the concept. What makes us different is we don't do anything in terms of caching. We're not about pushing data locally and optimizing it through that performance. We're about anywhere connectivity, and then optimizing how traffic goes back and forth. And what we typically do is, it's our software layer. Our software layer is doing real-time telemetry on all the activity over the network, and at any one time it knows what is the optimal route. So it's constantly creating these optimized private tunnels from anywhere to anywhere based on the two people or the person trying to connect to this infrastructure. The key there is we're always doing the optimization on things like, we're looking constantly at packet loss, jitter, right, and latency. We're doing a MOS score. So we're doing an MOS score and saying this is the best path. Every 9 seconds we reevaluate. So as it's happening, those paths may change. So it's not a simple back and forth, here's your calculation. It's constantly what's the optimized route throughout that whole engagement. So it's really the infrastructure and the network topology of being an Anycast network to simplify how we ingress people onto the network, and then the software layer in terms of logistically constantly optimizing the network and creating this, I'll call, optimal performance for applications and business use cases.
So that's going on throughout, like at a 30-minute live video conversation.
You got
this. That's going on throughout it every 9 seconds.
Every 9 seconds is trying to and we did that because we could do it constantly, but then you're flipping the route too much, right? So every 9 seconds we're like optimizing it. Now, we've roadmapped how we can do multiple packet sends so we can guarantee performance, right? So that's some of the stuff we're doing in the future, but it's always about how we optimize the ongoing back and forth of that traffic. Think about, we built this network for Web 3.0. Think about metaverse rich use cases. But obviously in modern times, anything like work from anywhere reality that exists and people trying to log in through VPN, VDI, or even WebRTC use cases where users can be anywhere. How do we optimize that experience through basically us being the transport for the developers?
Right, right, absolutely. Yeah, and you mentioned earlier that you're not doing the optimization through caching, so that kind of gets to the question of, which caching is not going to help so much when with a live video situation,
You
right?
got it.
So, what challenges do exist still in networking for live video specifically, and how does Subspace address those?
Well, great question. So as you said, a caching is not going to solve the sort of latency and packet loss of that ongoing conversation. Now, the thing is, with WebRTC, you've got two options. You can use public internet, which is easy, simple, global, right? But you've got a network of 40,000 networks with no commitment to an SLA or anything. So it's best effort. So now developers are trying to figure out, okay, how do I solve that? I'm writing it in my code. How do I optimize it in the software itself? I'm building out maybe more infrastructure and data centers to accommodate sort of regional connectivity. So that's a lot of cost, a lot of troubleshooting, and what we're trying to do is simplify that. Don't worry about that. Your footprint doesn't have to be massive to touch the globe. Tap into the network. Let the network solve the latency. And solve the sort of issue of the whole experience, and then just focus on the performance and user experience of the software. I saw this. I was at. It's actually interesting you brought up the topic because, I'm a little bit a newbie into, so let's say, the collaboration, the streaming space, and when I went to the NAB show, I saw the solutions. The solutions were massive trucks of equipment and hardware to do, latency of real-time replays. I mean, it's crazy. Like, the spend to solve the problem is massive hardware infrastructure.
Right.
And this is sort of a very disruptive concept. And we won't be the only one, right? Everyone in this space is like, it should be a network, right? The network can solve the problem. Focus on the application, make it as lightweight and as efficient as possible, and let the network do the heavy lift and how it optimizes the environment itself.
Yeah, I think I can safely speak for both of us when I say there's no networking truck outside of my office here. Probably not outside of yours either.
No.
And that's not the mode that outside of large conferences and events, and like NAB, that's not the mode that people are using for this.
I mean, it's like the anywhere to anywhere. The audience could be anywhere. So that doesn't actually meet the needs because you don't know where you have to move the truck. And then the flip side is even all the major, let's say, meetings providers, right? They built out data centers regionally to accommodate this.
Yeah.
But what's, and I think everyone can agree to this, the traffic that's consuming video nowadays is probably 10x what those products were built for originally. And they're struggling to figure out, okay, as I get more users and more geographies using the services, what's the solution? The mindset is more data centers, right? More SFUs, more processing, versus someone stepping back and saying, okay, is there a better way to do this, right? So things like, in network optimization, but also edge computing. Could I move those SFUs to the edge, right? So I'm running that piece along the network and optimize the architecture. So there's a ton of potential to re-architect the way we deliver video services and even WebRTC itself.
Yeah, absolutely. Yeah, it's not only a 10x increase in traffic from what people were expecting in a lot of those last mile installations, but different types of traffic too, right? The dependency on video in particular is something that I think has certainly happened faster than people expected because of the last couple of years.
I don't know if you had the same experience as me, but before, and my background is in video. I mean, I had a startup 20 years ago that built WebRTC meeting spaces, which eventually became Avaya's Spaces. It's the product they have there. And I ran their API as a service over there. And I remember we were talking about all this technology and the way to build these platforms. But I mean, when you went into a video meeting, maybe one person had video. Everyone was like, no video, mute, this and that. Nowadays, the dynamics change so much that if video's not on, you're sending a signal that you're not paying attention. Right. So now you have again, the video is not a nice to have. It's a mandatory requirement. And the video element is democratized, meaning it's the must have. Now, where's the innovation? The innovation is more that sort of, how do I create that real experience, so that more engagement experience when I'm in the meeting itself, which, guess what, is even more taxing on that. The internet wasn't, the basic network weren't built for that. And, yes, there is a way to solve it, which is lots of hardware, lots of infrastructure. But is that the best way to do it, right? Is that
Right.
really going to be scalable based on more and more use cases that you want to build into those immersive sort of platforms?
Yeah, absolutely. And so you know this really from personal experience of having worked with Avaya Spaces so many years ago. Building these live video applications it's still really complex to build, right? And even more to scale. Even as WebRTC itself as a standard has become more mature, there's still a lot of complexities in it. So, what are the complexities that you see in um, scaling WebRTC in WebRTC application development in general, perhaps, or in scaling in particular, and how Subspace addresses those?
Yeah, so I mean, it's sort of things I've talked about it. Like, so as a project, like open source project, it works. Like, hey, you get it up, it's running, it's lightweight, anyone can connect and it'll work. And the problem is, like I said, like the one option public internet is very easy. It's sort of peer to peer, but you have absolutely no assurance that the network's going to meet your needs for that point. So how do you architect it? You're building out data centers, you're building a hardware turn, right? Turn becomes an element. I can use turn to sort of support instead of peer to peer to do those connections. The problem with turn is you're going to sacrifice performance. And most of the WebRTC people I deal with, they're like, turn is only if it's completely messed up, or like it's such a small portion of their traffic because of costs or because performance. So
Right.
it's like I can get guaranteed stability, but I got to sacrifice performance, or I can have performance and have no idea whether I can apply, especially if this wants to go mainstream into the enterprise, SLAs
Yeah.
and support for large volume, large scale, even early on developers works good with 6 or 7. You get to 10 or 12, things start going off the roof, right? So these are the challenges that you articulate. The challenges is with WebRTC, because I'm seeing growth everywhere, gaming, corporate, collaboration, is how do we make it scale to meet enterprise needs without affecting performance? And that's where we believe we come in, is we're going to provide that network as a service that's going to give you, right, stability, 100% SLA, but the key thing there is performance. You're not going to sacrifice performance for security because of the network. We're going to immediately provide DDoS mitigation by, pushing people ingressing at the edge, right?
Yeah.
As well as we baked into the network turn. So it looks like so you have 137 POPs that look like individual turn servers all over the world. But from a developer standpoint, it looks like I'm connecting to one turn server, right? So I
Yeah.
simplify everything. But the key is it's not a turn server. It's just using the turn protocol so it's easy to support the network and ingress. It's actually in the call path. So you're going to get performance. You're going to optimize peer-to-peer, all connections, but have stability. And that will allow the developers to focus on that user experience and scale. So instead of building out, 30 data centers of the world, they build out, let's say 5 if they want to cover geos. And then we become the extended network to, really extend the performance to that local area or wherever the user may be within the world itself.
Excellent. Excellent. Yeah. So that brings it. And for our viewers, you're welcome to ask a question just in the comment section of whatever platform you're watching this on. And you're starting to touch on, I think, a question we have here from Guillermo Prado. Is Subspace then a private network?
Yeah, so I'll call it semi-private. We have our own fiber, right?
Mhm.
But we look at the whole internet. So what we're doing, think of us as ways for the whole global internet, right? We're analyzing the best path. So we're not going to always use our network. We're going to use the one that's most optimized. So we're creating private channels constantly, but it's traversing over public or private networks. So I call it like semi-private, right? You're creating private, direct, optimized channels, right,
Yeah,
or tunnels on the fly, but it's using public internet, a
absolutely.
combination thereof, right? So
Okay.
we'll buy fiber or circuits where we think, wow, this great capacity is going to speed up, right? Every millisecond counts, but it doesn't necessarily mean we're going to use our network constantly.
Right.
Again,
Okay.
public internet. The thing is I don't want to shoot down the public internet works, but
Right.
it's like, if you look at it, it's up and down. What we try to do is we're going to give you a performance that's constantly at this measure, because we're always finding the best routes through these
Yeah.
private sort of tunnels that we're creating.
So you were talking about turn servers earlier. Is
I Someone had to ring my
live
doorbell.
internet?
Hold on.
No worries. The uh,
Yeah.
you were talking about turn servers before. So is Subspace a replacement for turn servers or a complement to them?
So it really is a replacement for Turn. So the idea is we look like Turn, so it's not a major replacement, but it's a completely disruptive idea of leveraging us as that Turn network
Yeah.
with none of the Turn like performance issues, right? So it's like a whole new replacement for Turn globally.
Right, right. Okay, that's great. Yeah, and that's probably going to be welcome news then to a lot of our listeners, right? Because configuring and setting up the turn is definitely an area of risk as well as an area of cost in building all of these applications. So you're removing a lot of that then, which is excellent. All right. Another question from a viewer, Casey McDonald asks the reevaluation of the network. You talked about that being like every 9 seconds. So that sometimes does result in new routes during the connection between different backend nodes or kind of between client server. How does that work?
Yeah, that's exactly it. So some of the things that we do that's part of the intellectual property of the software is we can actually move packets dynamically to nodes in transit. So let's say things went down, the
Mhm.
users wouldn't see, they might see a blip and then we're over, but by moving packets, we're dynamically moving packets based on the route change on the fly. It's exactly what we're doing.
Excellent. 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 What sort of interesting use cases are you seeing being deployed with Subspace?
Well, this is why I love being at Subspace, right? Is the amount like I mean, listen, I come from the WebRTC space, but my roots were meetings and collaboration, right? So I
Right.
was thinking, okay, next gen is really contact centers and UC platforms, but that's what we've seen is like it's dynamically being leveraged into all these unique things like healthcare. So yeah, you're thinking telemedicine is a basic one, but things like surgery. So
Yeah.
we have an organization that has doctors around the world doing remote surgeries on live like bodies and patients using WebRTC to control the devices in the surgery room, which is like, wow, like that blew my mind, right? And then I laugh at this one really. It's like drones. Like so people are like, so yes, autonomous drones are awesome, but people in different parts of the world are saying, well, it's too expensive to put processors into the drones. So they've got these drones where humans are controlling them halfway across the world with WebRTC, right?
Right.
Controls, like things of that nature. And then you're seeing all the standard stuff. Like we're seeing WebRTC in gaming, watch party events, things like that nature. So the whole audience interaction is next gen, but it's emerging very quickly. So we're
Yeah.
seeing a ton of that, as well as like every major contact center CCaaS provider, WebRTC is the standard. So it's in the traditional, but we're seeing, again, even in the meetings, that sort of metaverse, virtual offices, virtual parties, virtual events, WebRTC is like, center stage, right? So we're seeing it cross, education, healthcare, media and entertainment, gaming, you name it. It's all over the place.
Yeah. Yeah, I mean, it's very cool for you to lead with something like telesurgery, because that's the sort of thing a few years ago, there was a time where I remember writing a blog post. It was like, three things WebRTC cannot do, right? And, blog posts like that would include something like, well, let's not do surgery with it, but you can do really good meetings, right? Now we're getting to the point, maybe you could do surgery with it, fly that drone remotely.
Exactly.
Hopefully we're not going to crowdsource the surgery to anybody who wants to do it online. There's
No,
still
but
some practical limits,
but you
but
think about it, right? You can get the best surgeons in the world to do the most critical surgeries, right? Like,
right,
you can get
right.
the best now doing things. That's where I see it, like you said, really disrupting and changing the way we do things. And again, WebRTC is that perfect platform, but the challenges are scale and think about surgery. You cannot, I mean, think about is public internet. Would you do surgery knowing it's running over public internet and all of a sudden we have an Amazon
Right.
outage or, you know what I mean? Things of that nature.
Yeah, absolutely. Guillermo left a comment, by the way, that he saw the guy outside that your dogs are barking at.
Yeah.
But
I have someone doing
he's
work at my
gone
house
now.
and I think they're trying to tell me they're done and my dogs are barking.
um, yeah, I mean, and that aspect that you mentioned like an SLA, service level agreement. I think that's one of the interesting things about this too, of how it impacts WebRTC application development, because in the past or even recent past, when someone talks to us about building an application and we talk about quality and stuff, we talk about the things that we can control and how we build the application. But it's difficult, or at least it was difficult, to really give a true SLA around video quality, because there's so many things you don't control in between the users on the application. And so I think that's, one of the things that's exciting to me about this is, regardless of whether we're building something for telesurgery or not, having the opportunity to say that there is a certain level of guaranteed stability in the network, that you're erasing those peaks and valleys is really compelling.
I mean, listen, I'm sure you've all experienced. Before this call, I was on a major meeting with a big bank discussing critical topics, and guess what? It was Microsoft Teams. I was zeroing out every other second because you don't know public internet what's going to happen. It's probably local here in Canada, right? So we take it for granted, but the more and more we use it, the more and more we're going to feel the experience, and it needs to get solved. So that's why, my excitement with this is it's meeting a need. When I think about like network connectivity, stabilization, SLA, it's meeting a need to foster the growth for WebRTC. It's not the only thing. There's so many other things for WebRTC, but we think we can be a critical player and help people grow their businesses and use cases, right, at scale.
Yeah, absolutely. So, so on that, the performance topic there. So since Subspace it's really about providing that global network. You don't need as many different duplicate servers around the world, because Subspace can kind of help you bridge those geographical gaps with better performance. But I assume that the biggest improvements in performance would be when someone is using the Subspace network over a large geographic region. Is it fair to say that, if you're down the road from me, you're not going to see as much improvement when using something like
I think
Subspace?
it's a great point. So obviously, North America has good density. So let's say from here to there, we're both in our local ISP. Our impact could be something, but it's going to be very, our impact from me to someone around the world is going to, the further it is, the greater impact on the performance we're going to deliver. Absolutely. So it's a question of distance as well as consistency. So let's say we're on a video meeting. Over an hour period, it might start off amazing, but it just starts to degrade. I mean, it happens all the time, especially if you have multiple people. So what we're going to do is, regardless of geo, is the stability. So the longer the session and the longer the distance, the more impact we're going to have on that experience.
Yeah, that makes sense. And in a more local scenario, the impact is going to be something similar to turn. When there's just, even though you're close together, there's a difficulty in the network and reaching somebody. Subspace can help with that in the same way that a turn server would.
You got it.
So with the way that telemetry works across the network, then I assume it's also that the more there's a network effect here, right? The more people who get on the Subspace network, the better the Subspace network will be. Assuming that's true, how big is the Subspace network now?
Yeah, no. So it's a great point. We call it a learning network. I mean, the more you use it, the more we understand the behaviors and patterns, the better we can optimize the traffic. So anytime we get a new customer, it benefits everyone on the network, because we have more patterns and more ways to evaluate routes across different geos or different routes around the world. Today, we basically have like over 400 million users daily on the network. So it gives us a good baseline of telemetry, and it's growing, right? So that gives us a baseline of how we optimize, right? And then obviously the software layer is constantly looking at network traffic and optimizing beyond just the user behaviors.
Right.
But like I always say, like day one, it's working, but it only gets better from there, because like the popular routes are good, but you might have routes that no one's using. So over time, it'll get better and better and better.
Yeah. And speaking of new routes that not as many people were using in the past, and now sadly are due to geopolitics. An interesting question here from Miguel Juan. So the internet through satellites like Starlink is playing a fundamental role in scenarios like Russia's war in Ukraine. So does Subspace work the same way in that type of network? Do you know if it's being used over Starlink?
So Starlink is just another network. So if, let's say 40,001 network that what we try to do is and we're connected to it too, right? So we're peer to it. So the idea is It just gives us more network to optimize how we move traffic itself. Now, the cool thing is, like you bring up the Ukraine situation, is we have POPs in the Ukraine and bordering cities. So if things go out, let's say in the Ukraine, we're going to ingress the network just outside, like where the next
Right.
closest POP, right? So we can provide resiliency. And that's some of the discussions, we're having, is around how can we help, like a network like this, almost like a private end-to-end network. People, let's say outside of Ukraine, trying to communicate with people in Ukraine. Public internet's like probably not a thing. So if you combine Starlink and the way we optimize traffic from anywhere, it
Yeah.
can create value.
Yeah, that's really interesting. Yeah, and that's a a, a, a very important example of how there's performance, but then
Yeah, because
resiliency too.
listen, Starlink, you're going to get on the network quick, but the other user's not on Starlink; he's somewhere else, right?
Right.
So how do I optimize once I'm on Starlink to the other user who can be anywhere? That's where Subspace and Starlink together create a good combination.
Yeah, absolutely. So some of the as we as the pandemic hopefully is easing, some of the estimates of WebRTC traffic show that we've kind of stabilized as the pandemic has started to ease. Video traffic is still a lot higher than it was a few years ago before the pandemic, but not at the peaks of 2020, where there was the most disruptive phases, the most schools closed and workplaces closed and that sort of thing. What sort of traffic what sort of growth do you see in WebRTC traffic generally, and on the subspace network specifically?
Yeah, it's our biggest growth. I mean, our roots were in gaming, right? Anywhere to anywhere, and
Mhm.
that's where we have a lot of the user traffic. But if you look at the last 6 months, most of our growth traffic is all WebRTC use cases, and they're like both combination of CCaaS and these immersive meetings platforms that, again, they're beyond just us meeting. It's like virtual office, collaborating, engaging with other people, right? So we're seeing more users and
Mhm.
more bandwidth because it's beyond just the video element of it, right?
Yeah. Yeah, so now even if some people are going back to school in the office, that sort of thing, and so some of those people are leaving the traffic as really our lives have changed, and now I think we expect more from what we're doing online as well, as work from home becomes more permanent for many people, but also the way that we work from home is changing as we adapt
Well,
to it, right?
it's a good point. It's not so much work from home; it's work from anywhere. Meaning,
Right.
the people who work from home
Right.
aren't necessarily at their desk. They could be at their cottage, they could be outside, they could be here, they could be
True.
on their mobile, and then you have this growth in hybrid, which is, Monday and Tuesday I'm in the office, the rest of them at the week. So WebRTC actually has a strong play there because it's a work from anywhere dynamic. That's why we're seeing a lot of growth. Because could you
Yeah.
imagine traditional video with codec, like trying to manage and maintain that? It's not feasible, right? Like
Right.
it just makes it feasible.
Yeah, yeah, that's a great point. Work from home, the home part specifically, might actually be your best connection now,
Yes, yes.
instead of your second rate one in the past.
You
So,
got it.
yeah, for our viewers, we have time for about one more question. If anyone else wants to pop one in there before we wrap up, but Dave, tell us a little bit more about how Subspace integrates with existing applications. Do you need to rebuild an existing application in order to get it to work? Does it matter what tech stack you're working with? How does that integration work?
Yeah, perfect. So that's one of the biggest things we pride in ourselves is how easy it is to consume the network, right? So you're not
Mhm.
re-architecting anything, you're not redesigning anything. If depending on the use case, like if, for example, if you were just optimizing VDI or VPN access for remote work from anywhere, you just go to our portal, you put in the IP and port of the servers they need to connect to. We give them a subspace port and IP, and it's a network config, and they're up and running. For developers who want to bake the network into the application, we have documented, they go into the portal, there's documented APIs, and there's different interfaces. So if you want to integrate it on the server side, right, we have our packet accelerator and our API where you can dynamically create those tunnels right from the server end. So nothing on the client side. For
Yeah.
WebRTC, to make it even easier, so it's less work, right? We give you the ability to bake it into the client side. So we look like a turn server, right? So we bake turn into the Anycast. On your client, you just make us another turn server on your list. Maybe you configure us under relay, and you're up and running. In fact, one of the best things we just did is we also have an SDK. It's open sourced. So, there's no risk. You can actually at any time look and say, is public internet good right now? Okay, I'll just use that because it's low cost. Oh, it looks shaky, I'll use Subspace. So dynamically, you can pick and choose when you use Subspace as well based on the circumstance.
Oh, that's really interesting. Yeah, that's a great option to have. Yeah, and that leads into kind of my last question, to just kind of give us a little idea of how the pricing works.
Sure. So it is consumption based. So it's it basically is a price per gigabyte. Depending on the vol, and it's a scaling. So it's, if you logged in as a developer and we're testing, we're going to give you 10 gigs and it starts at about 29 cents a gigabyte, but it dramatically drops based on your volume and how much data you're moving, right? So again, it's pretty low cost based on what you want. It's pretty low cost to get a global network with an SLA with in-network apps like global load balancing and DDoS per gigabyte. And again, with the SDK, because you can pick and choose, you're only paying when you believe it's required for that moment until you feel really comfortable and you decide I should use Subspace all the time.
Excellent. All right. Dave, this has been a great conversation. I've learned a lot, and I'm sure our viewers have as well. Any other final thoughts on your part? Anything else you want to make sure you covered today, and how do people learn more about Subspace?
Yeah, no, I think my sort of parting thoughts are this, right? I'm amazed how rich and how much and the growth I'm seeing in what I call the WebRTC community. So people like yourselves and others that I've been engaged with in the last 6 months, you guys are sort of shepherding and evangelizing what it can do, but we're starting to see a lot of innovation. Sometimes costs sort of stifle innovation, especially costs at scale. So I think that, this is where we want to come in. We want to sort of simplify growth, scale, launching, and being able to sell into what I'll call more enterprise space, and to learn more about what we're doing, because what we have today is the baseline, right? So that concept of in-network apps is what we want to do. More and more value-added services that you can just turn on and leverage around the global network, around in-network services. You would just go to subspace.com. Okay. And I highly recommend anyone who's building an application, sign up, you get a free account, and then you can start playing and testing with it just to validate everything that we're saying.
Awesome. All right. Well, thanks again for joining us, Dave. Really appreciate your time and the conversation. Look forward to speaking with you again. For our viewers, as always, this video will be available on the WebRTC Ventures YouTube channel, as well as on our blog at webrtc.ventures. Thanks again for joining us today, Dave.
My pleasure, and I apologize for the dogs. We got through it.
We got through it. No worries at all.
All right.
Our next episode will be Wednesday, June 15th. We will be talking with Sean Dubois from the Pion Project. So join us for that. We'll get an update from Sean. It's always a great conversation. Find out more about our upcoming episodes. Follow us on Twitter, LinkedIn, YouTube, Twitch. Join our email list at webrtc.ventures. Thanks, everyone, for joining us today, and let's make it live. As a viewer of WebRTC Live, you already know how important WebRTC development is to the modern web. Now it's time for you to grow your career by learning to build live video applications and joining our team at WebRTC Ventures. Go to webrtc.ventures and apply to join the next cohort of our WebRTC training program. You'll have free access to advanced courses, mentorship from our team, and those who are accepted into the second month will receive a paid development contract and join our team of WebRTC development experts. Go to webrtc.ventures now and earn your place in our team of video development experts.
Thanks for joining us for WebRTC Live. Visit our website at webrtc.ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.